Hello, my name is Bradley Wilkerson. I'm working on question 5. I'm doing A and B. So for A, we're trying to figure out what the offspring would be for an orange male and a tortoiseshell female would be. So this is for the X-linked inheritance. So a little b equals orange, a big B equals black, and then a big B, little b equals the tortoiseshell. So the orange male is going to have an X and a Y chromosome. On the X is going to be a little b for orange. The Y doesn't carry a trait. And then for the female, since it's a mixture of both of them, they have both X's, and one's going to be dominant B, and the other one's going to have a recessive B. And take the Punnett square. This. We get 2 females. One is going to have the tortoiseshell, and the other one is going to be orange in color. So 50% of the females are going to be orange, the other 50 are going to be this tortoiseshell. For the males, since they can only get their X's from the mom, one will be black coat, and the other male offspring will be an orange coat. For number B, for B, letter B, what is a male tortoiseshell? What would the genotype of the male tortoiseshell would be like? For that, 2 X's for a tortoiseshell. The male would have to have 3 sex chromosomes so that it has the 2 X's. This will be dominant allele. The other one will have the recessive allele. That way they split up, and one is inactive, the other one shows, and then when the other one's inactive, the other one appears.
Okay, I'm Donovan Wixom, and I will be doing C and D of this problem. For C and D, we're asked to do reciprocal crosses. Can I get the marker?
No.
For C and D, we're asked to do reciprocal crosses, and C, we're told that it's X-linked. So B for the wild type allele and little b for the mutant allele, just because you can tell B's apart really easily. So to do a reciprocal cross, the mother has to be homozygous. So we're going to make her big B for right now. And the father has to be opposite from her. So we'll make him little b. And then you just complete your Punnett square. So I'll ask for the genotype and the phenotypes. The results of your Punnett square are your genotypes. And the phenotypes for the females, because they each have a big B, they're going to be normal. And for the males, since they each have a big B, they're going to be normal. So the phenotypes are just 1-to-1 male and female. Everybody's normal. So then we have to do the reciprocal version of that cross. Can you see that low? Yeah. Which means the mother is going to be homozygous recessive this time, and the father is going to be dominant. So we get okay, so again, the results are your genotype. The phenotype for the females is they're going to be normal because they each have a big B. And all the males are going to be mutant because they have little b's. So we have different phenotypes for the two reciprocal crosses, and that's indicative of an X-linked trait. For part D, we're told that it's autosomal. So we just have to make sure that one parent is homozygous dominant, the other one's going to be homozygous recessive. And we just do a normal Punnett square. So your genotype is only going to be heterozygous, and that means your phenotype, everybody is normal. And to do the reciprocal of that, it's literally the same Punnett square. You just switch which one of these is on which side. So you're going to, again, have heterozygous, everyone's normal in the phenotype. And since both the crosses are the same, that's what shows that they're autosomal.